This video is for Chapter 2.2, Organizing Quantitative Data. So what do we do after we collect this data? We are going to do statistics. We have a question. We collect data, and now we want to summarize the data, see what story it's told. So we use different ways to do that. We have some popular displays. We have some types of tables, histograms. We use stem and leaf plots, dot plots, and then after we make these graphs and tables, we then look at a question called we ask a question, what's the shape of the distribution? What does the graph look like? And so we have some language we talk about. And so the first step in summarizing quantitative data is to determine whether data are discrete or continuous. And so you would fill that in on your note sheet there, discrete or continuous. And if the data are discrete and there are relatively few different values of the variable, the categories of the data we call classes will be observations, as in qualitative data. If the data are discrete but there are many different values, or if the data are continuous, the categories of classes must be created using intervals. And so let's go ahead and make sure you get that information in. And so now that you have that information in, let's go ahead and look at an example. Here is some raw data based on the number of customers who arrived during a lunch hour. And the data represents the number of customers for 40 randomly selected 15-minute intervals during lunch hour. So let's say the manager wants to count every 15 minutes how many people come in, and these are the results of that over 15-minute intervals. And so how do we summarize this? Well, let's construct first example is construct frequency and relative frequency distributions from discrete data. And so this is similar to what we've done before. We just want to kind of organize this. And doing it by hand will take so much time. So in this class, we use StatCrunch often. And so in StatCrunch, what we have here is, here's the data for this set. And so if we wanted to summarize that in a frequency, what we call a frequency distribution, we want to see what the data looks like. We just go ahead and make a frequency table. We would do that. I'm using Wendy's data. And then we want, so it's a frequency distribution. And so in this case, I have frequency and relative frequencies set here. And then you hit compute. And then you go ahead and then you get this distribution that looks like this here. And so this is what is the table of values that you would put in, is what we would put in to this part right here. This is a frequency distribution. We can see how many times. So, and so interpreting this, like for example, what this means right here would be that over 15-minute intervals, 5 times 7 customers came in, right? And that happens 12.5% of the time. This means 11 times 6 customers came in to Wendy's, and that's 27%. So that's the table that you would go ahead and put into your notes over there. And so again, this is what you would have in there. This is what a frequency and relative frequency distribution would look like. It tells you how often these things occurred. Organizing raw data. This is again, it's important to acknowledge that this right here, right, this is what we call raw data. And then it goes down here, this is organized data. And this is where we show you the different techniques to organize data because it's easier to read here. So that's what we're looking at. Let's go ahead and take a look at one more here. Example now is talking about histograms. And so to show you what I mean by histograms, you can see different ways here. There's our example. What is a histogram? It's constructed by drawing rectangles. So it's similar to a bar graph. The only difference is the width of each rectangle is the same and the rectangles touch each other. The height of the rectangles is a frequency or relative frequency. So keep that in mind. It looks very similar to a bar graph, but there's some subtle differences and more technical differences. And we did this again. If you come from Math 83, we've done this. And so if you have a frequency table, what we do is we convert frequency tables. Here's an example of a frequency table. that gets converted into histogram. And again, the difference is in a histogram versus a bar graph. In a histogram, down on the bottom here on a histogram, right here, this is quantitative right there. The x-axis is quantitative, and so versus it being categories, which we had done earlier, qualitative data. These are quantitative, and so that would come from there. So let's go ahead, and the thing is, we're not going to do this, and so you can see it's the frequency, how often. So around 22 times. Where is it? 22 times. 22 families have 2 cars. 7 families have 3 cars. And so you can see how that materializes here. And then looking at it, we could also graph it as a relative frequency histogram. And if you look carefully here, you can see there's percentages here on the side, or the decimals, which are the percentages. So let's go ahead and show you how to make one here. Let's first make sure you fill in the blanks here. And so here is our first example, drawing a histogram. Again, we can do this by hand, and we do that in earlier classes. Here we're going to use technology to do that. Let's take a look, and that would be StatCrunch again, is where we would do that. Let's see where I have this information right here. I have it right here, the number of customers. Let's look at that again. There, wrong one. Number of customers, the frequency and relative frequency. And then we want to make, using StatCrunch, we would go to graph, histogram. And then what we have here is, again, all of this data here. That's what the table looks like, but we're going to use this raw data. So if I choose Wendy's, here's all this raw data. We want to make we're going to make a histogram. Here's a frequency histogram. And then you just hit compute. Get there. There is your histogram, your frequency histogram. And so there's the graph from StatCrunch that we created. It's a frequency histogram. Frequency means it's telling you how many times there was one customer one time. And so you can see this is what we would then describe. What is the distribution of that? We then can also make a relative frequency histogram. So again, it would be in the same place here where you would go graph, histogram, and then pick that and then change this to relative frequency. And the thing again is going to look identical. Oops, I need to choose what I want, the Wendy's data. Compute that, and then you see it's going to look identical to the one that we had. Let's see if I can copy that in there. So we could compare it over here. We could compare it to that one here. And the key is that they look identical to that. So take a look at that one compared to the relative frequency we have here. They're going to again be identical. And so this is what I mean by identical, and the shapes are the same. The only difference is the relative versus frequency. You see these are in decimals and these are the actual values. And so that's a histogram, a relative frequency and frequency histogram. And to finish this at least video off, we want to complete our notes here. On here we have a term for you that I used once already, but I'm going to use it again, at least define it for you now. The word we hear is classes. Classes are categories into which data are grouped. One data set consists of a large number of discrete values, or when a data set consists of continuous data, we must create classes. We create classes by using intervals of numbers. And so again, that's from our PowerPoint, which you can get all this information from our PowerPoint. We end up using intervals of numbers to make our classes. Intervals of numbers. And there we go. So that's part one of this video.